This conference will now be recorded.
So today is just basically a review. You do have exam number 2 this week. Remember, you need to make sure you take it no later than this coming Saturday. Double check that wherever you're taking it does have Saturday hours if you're planning on taking it Saturday. So remember, you do have to schedule yourself a time online there. And all those directions are in the syllabus there, just like for exam number 1. So I'm going to take you through a couple things that you want to make sure you're preparing for this exam, and then I'm going to go through the highlights of here's the main parts of each section that you really want to make sure that you know. So first of all, when you come over here, before I also start, excuse me, if anyone is using ProctorU, please let me know because I have to send them the information. I do not believe I had anyone use it for the first exam, but if you are going to be using it for exam number 2, I need to know. Okay, so over here in Module 6 is where we're at. You can say it says exam number 2, and then next week we'll start talking about sections 13 and 14. So let's take a look at this. All right, so here in Module 6, don't forget I had a few people who forgot to do the practice quiz for exam number 1. This is very beneficial, so I want to point this out. So over here it says review quiz for exam number 2. This is a required quiz, okay? So once you get to this, it's going to take you to another outside link, another book page in in Ivy Learn. Excuse me. And notice there's 20 questions each time you take it, and it does have a time limit here. Excuse me. So you want to definitely make sure that you are doing this because I do count the grades. So I will count the grades after everyone has taken the exam. So you have the opportunity to take this multiple times before exam number 2. And the highest grade will count, of course. Now, one of the things to keep in mind is, go ahead and take it the first time. Just keep your reference sheet with you and try to take it on your own without looking at anything else and see how you do. Then you're going to know what areas you had some difficulties. Then those are the areas you want to go back and double check and, what did I do wrong? Did I, use the wrong formula? Do I not understand something? And if you need me, remember, just shoot me an email and I'll help you with that. But this is the best way to do it. Then take it a second time. And if you can, take it a third time. I can tell you there is almost a direct correlation to what you get, the grade you get on the test review here compared to what you get on the actual exam. It's almost a direct correlation. It's just a few percentage points, difference, maybe 1 to 2 higher or lower, but it's very, very close to what to expect for the actual exam. Okay, and then once again, make sure you're using the scrap paper and that you're numbering your work so I can see what work goes with which problem, because the testing center will give you some scrap paper and they're going to give you the copy of the review sheet, because I had put on there, please give a copy, of the reference sheet, reference sheet. So those formulas are going to be there. So be familiar with what's on that reference sheet, what formulas are there, okay? And you'll be able to use all of that. Okay, so don't forget to do this. That's why I pulled this up to make sure you noticed it. It's in Module 6 under, Test 2 Review Quiz, and you want to make sure you take that. Okay, so what is going to be on the exam? I'm going to start with section 7 here. So we had interpreting change, absolute and relative change. So you want to definitely know the difference between the two. So remember, absolute change is just the difference between the numbers. Okay, the tricky thing is you need to establish which is the new value and which is the old or the reference value, because it does make a difference, because a number can be positive or negative for the absolute change. So in this case, the example showed the US population in 2006 compared to 2016. Well, this is a little obvious because they're talking about years. We know the older value or the reference value was in 2006. And new is usually where you're going to, kind of rhymes together. And that would be the 2016 value. And that's why we have um, the 323 million minus 298. Now, notice if they're both in the same units. Okay, so if you're dealing with both in the same units, you can simply use the number and then attach the units at the end. Okay, so that's one of the things that you want to keep an eye on and remember that. It's always important to remember those units at the very end. So this was a positive value that meant the population increased. So if you had to interpret this, which there'll be some spots on the exam where you'll have to type in what something means, make sure it makes sense. Okay, go back and double check and reread it. Okay, so here's something like that. Okay, now the other way of describing change is relative change. And so basically the relative change is also referred to as a percent of change. Okay, so it's a percent change. And so we're going to take that absolute change, in other words, new minus old, divided by the old. So you're referencing it based on the old value. So this does make a difference which number you divide it by. And that's probably one of the biggest mistakes I see. People divide by the wrong value. Okay, so relative change is not going to have the units because the units wind up canceling each other out. So in the same idea here with the same exact problem where we're dealing with population and they were in the millions, if I have millions divided by millions, millions is going to cancel out. And I'm going to get a decimal as an answer. What you want to do is pay attention. Do they want the answer in the form of a decimal rounded out to so many digits, or do they want the answer in the form of a percent? So that's the one thing you're going to watch out for. Most of the time, they'll ask you to convert it to a percent. So just like the homework assignments, just watch how they want the answer posted there. I do have to take points off if you do not round it to the correct number of digits there. So watch out for that. Okay, so in this case, it increased 8.4%. And here is a possible descriptive sentence that you could make about that. Okay, so the two big areas here are absolute and relative change. Okay, so if you were given something like this about fair market rental rates, and they're asking you from one year to the next, that's pretty easy to figure out absolute and relative change because the old value is the one in the past. But when we get into numbers that maybe I'm moving from one location to another, let's see, was it? Okay, in this case, I'm moving from Terre Haute to Indianapolis. Okay, so that meant my old value was Terre Haute. Okay, so remember, this is going to be new absolute change, new minus old. So in this particular case, I'm going to Indianapolis. So that's 792 minus the old. Okay, and then notice if we take the new minus old divided by the old, here's our percent change. So it increased. But if I'm going in the opposite direction, okay, from from Indianapolis to Terre Haute, these numbers will basically be the same essential value, only in this case, instead of it being a positive value, it's going to be a negative value here. Okay, in other words, if I move from Indianapolis to Terre Haute, my rent is going to drop $114. And the relative change is not just going to be a difference of a negative number. Remember, relative change is based on what the old value is. In this case, the old value is a different number. Now it's representing Indianapolis. So that's why we get a different percentage here when we go in the opposite direction. So be careful with that. That's another common mistake people make. They figure, oh, I'm going in the opposite direction. It's just a matter of a negative. But remember, in the relative change, it is a different reference or old value there. So your percent is definitely going to be different. So just watch out for that in that section there. Okay. Changes in percentage points. So when you're dealing with figuring out absolute and relative change and the data has already been given to you in the form of a percent, you're just going to use the number as is, and you're going to drop the percentage sign, and you're going to think of it as percentage points. Okay, so that is a possibility. You might see something like that. Okay, and here is an example. Okay, so what we did is we just dropped the percent sign. Notice we keep the numbers as is. I'm not converting anything to decimal form or anything else. So we just consider them as percentage points. So it's what? New minus old. So we can see that the unemployment rate from 2009 actually dropped 4 percentage points. And we say percentage points here. And the relative change was a negative number. In other words, that negative means it decreased 43%. Okay, so be careful. Don't say it's a negative 0.43%. Remember, relative change when we calculate it is going to put it in the form of a decimal. Relative change, no matter whether we're using the numbers, you know, that were percentage points or whatever, we always have to convert that back to a percent. Okay, so just watch out for that. Okay, inflation is the relative change in the CPI from one year to the previous year. So we can figure out inflation rates. We can also see if something came and followed inflation. You know, we can test numbers to see if, you know, here's the number they gave me. Is this true? Did it keep up with inflation or not? So in this particular case, it said find the inflation rate for 2016. Well, remember, if we're trying to figure out inflation, that is the relative change from the previous year, same time, but a year before. So that means we're going to be using the number for 2015 to compare it with. So when we go from the inflation rate actually increased 1.26%. Now, if something cost $1,500 in 2015 and it increases by 1.2%, that's like multiplying it by the percent in the form of a decimal. In other words, it's adding money to that. And so in this case, it would be worth a little bit more. So $1,518.92. So know how to do something like that. And then the other problem I wanted to go, let me see if this is the one. There's a problem in here that I want to make sure we do. Is it this one? Maybe it was over here. This is the inflation rate of a meaningful sentence. Okay, so I know there's a problem in here somewhere. I'm just not finding it right now. I think it's for the problem had a minimum wage, I think was something in here. Remember, if they give you two values, you can check if the value is correct or not Sorry, I'm just trying to find that problem. You can check if the problem is correct or not just by saying, okay, here's what they tell me the minimum wage is this year. If I actually calculated it using that as the unknown and calculate, the inflation rate, I can check if that value kept up with inflation, okay, by actually calculating what it should be. Okay, so you can always use the relative change to check if the answer is correct or not. Maybe that problem is over here in the percent of change. Okay, so remember percent of change when something is less than, so if we're saying something is 25% decrease, that means you're looking at what am I left with. So 100% minus that percent of decrease, that means I'm left with 75%. When it's percent more, we're going to take 100% and add that percentage. So it is possible to have more than 100%. Okay, so know how to do those problems there. So in this case, when we're talking about those fair market rental rates and we're saying the rates in Gary are 125% more than Muncie, that means we're paying 100% of what Muncie's rent is plus an additional 25% more. That's what that means. Okay, and we can use the idea of the proportion to calculate that. So remember, amount over the base is equal to percent over 100. If you know the percent, plug that in, and then it's a matter of thinking about it. The value that I have is the value that they've given me already after we've taken the percent, or is it before I've taken this percent? So in this case, they already told me what Muncie's rate is. That's not after I took the percent. Okay, so I know that that's the base. So remember, these two numerators relate to one another. Whatever this amount is over here is after I've taken the percent. So always kind of consider that, and it'll help you kind of determine which is the amount and which is the base there. Okay, and then here's another example with Lafayette's population and Bloomington's population. So that would be a good example. Okay, there's just a bunch more examples here, I think. Let's see what I got here. Okay, our relative change is additive. Okay, so remember, this is the thing where they say the company is having a hard time. They're going to decrease your salary by 10%, but once things get better, they're going to increase it again. Okay, so is that going to be the same? No, it's not, because if you decrease something by 10%, that means I'm left with 90%. And when I'm going to add 10% back, I'm adding 10% of that new number, not my previous value. Okay, so it's not additive. It's not going to get me back to the same amount there. So remember those examples that we went through there. Okay. And pretty much in a nutshell, that is what we have for section 7 here. All right, so let me go through section 8 here. Scatter plots and linear models. So a lot of times when we're going to be graphing information, sometimes we can see an overall trend, and we can see that that does form an overall trend, but it doesn't necessarily form a nice straight line for me to be able to come up with a linear model. So remember, a linear model is an equation of the line. So in order to come up with an equation that's going to best represent this situation, what I do is I'm going to be adding a trend line. Okay, so a couple things to keep in mind. The independent variable when we're graphing something is going to be along this x-axis, this horizontal axis. Whenever time is involved, that's going to be your independent variable. That's going to be your value of x. okay? Because time is independent. Time just keeps marching on no matter what. And the dependent variable is going to be the other thing that you're going to be graphing it against, and that's going to be on your y-axis, your vertical axis here, okay? And that depends on how much time has gone by, okay? So if I wanted to come up with a best estimate, I can create a linear model based on the best fit. Now, before we get into that, let's take a look at this definition of correlation. A correlation is just the relationship between variables. If there's a positive correlation, that means we see a positive trend. We see something going up to the right. Now remember, when we're looking at graphs, we always pay attention to where it's going to the right. Right-hand rules. All right. If it's going up to the right in general, that means it's got a positive correlation. When it's going down to the right, it's got a negative correlation. Now, we can also determine if it's got a weak or a strong or somewhere in between correlation based on how we see those dots in that scatter plot, our data plots. Okay, the closer the data looks to a perfect line, the stronger correlation there is. Okay, so these two right here look pretty doggone close to that line here. I mean, here's the actual trend line thrown in there, and here's what it looks like before that. This is somewhat of an increase, so it's about a moderate or in between. I mean, in the middle here, I've just got points of data all over the place. I don't see anything increasing or decreasing, so there's really no correlation between the data. And then you could see in the opposite direction. Remember, if it points down to the right, it would be a negative correlation in both of these cases. And so the closer it is to a straight line, the stronger the correlation. Okay. But remember, correlation is a mathematical relationship and it does not imply causation. So it's not telling you if the data is true or not. It's just saying if, how well that trend line fits the data points, how close they are to making a straight line. That's all that correlation means. All right, so I've been talking about this trend line, and here we have a trend line. So basically we can tell Excel to calculate that on its own, and what it'll do is it'll try to put a line in between so it has approximately the same values above and below. Okay, and it'll also give us the trend line equation. So this would be my linear equation for this particular model. Now notice this is just going to be an estimate because, these don't line up right on that trend line. Some are above, some are below. So the best thing we can do is estimate that value. Okay, so if it's asking you to use the trend line equation, you want to make sure you're doing that. What is my X value? We're going to be plugging it into the equation here, and we'll get the Y value out here. Okay. Now, if it asks you in this particular case, what does the slope of this line mean? So remember, the number in front of this X value, that value of M right here, this is my slope or my rate of change. Don't tell me the slope is, this number. I mean, I already see that. When they ask you to interpret what the slope means, you actually have to think about what is being graphed here, what's the situation, and what does that number actually mean in this particular situation. Now, since it's a positive value, that means something is increasing. What could be increasing? What's this graph talking about? Well, this graph is talking about CPI values. So if you were asked to interpret what that slope meant or that rate of change here, we could say that the CPI value is increasing 0.246 for every month from January 2011 to April of 2016. Okay, so remember when it's asking you to interpret that, what does that mean? All righty. Okay, and here's once again the definition of the slope. When we're looking at the equation of that line, so that equation of the line is, remember, it is that y equals mx plus b. Is that in this? Maybe I had it in the previous slide there. Okay, sometimes I can actually look and calculate the slope. Sometimes I have to, I'm sorry, I could see the slope or it's been given to me in the equation. Sometimes I have to calculate it. Now, slope is the unit rate of change in this case. How do I calculate the rate of change? Well, all it is the absolute change in the y values divided by the absolute change in x. So be careful, put these in the correct order. That's another common mistake that I run across, is that somebody will have it upside down. Remember, it's y over x. So you're finding the absolute change between two consecutive data points, okay? And then you'll be able to see what that rate of change is. So in this particular case, the rate of change is $6.49. So for every gallon of this, what is it, organic milk, it's increasing by $6.49 for every more that you buy, okay? Remember, the y-intercept is also referred to as b, which is our starting point, our starting value. Okay, and our starting value usually has to be a value along this y-axis here. Okay, so here is our equation of the line. So once you know your slope, once you know your starting point, those are the two things you need, you can always throw it into this y equals mx plus b to get your linear model here. All right. So remember, sometimes a linear model will be the slope will be decreasing. Like in this case, it was a weight loss plan and David lost 2 pounds per week. Okay, so his rate of change was a -2. So in this case, they actually told me the rate of change. Okay, and you could see what our equation wound up to be. Okay, whoops. Be careful. Remember, how long would it take David to reach his goal weight? So if he wants to reach his goal weight of 180 pounds, that's the Y value. So these are the steps that you would do to solve for X. Remember, we did a little bit of algebra here. Okay, so make sure you're referring to this and know how to solve this equation. So the first thing you want to do is get X by itself. So we see what's the furthest away. Is this 240? So we're going to subtract 240 from each side. I get -60 is equal to -2x. Divide by this number to undo it by the exact same number on both sides. A negative divided by a negative gives me a positive. So it's going to take 30 weeks for him to reach his goal weight if he loses 2 pounds per week. Okay. Let's see what else I have here. Breaking even, when we're talking about that and we're talking about money and we're talking about a linear equation rated to money, remember, if you're putting money out to buy supplies like they did for this sorority here, in this particular case, they were out $90 on supply. So when they came up with their linear equation, it wound up to be y equals 3x minus 90. Now, if they wanted to figure out how much money or how many shakes they would have if they wanted to raise $300, remember that's that y value again, and then you would solve for x, same way we just did before. But if you want to figure out how many they're going to have to sell to break even, you can set that equation equal to 0. So anytime you want to figure out that break even point, you want 1970, and this actually shows the year. All right. So in this particular case, this value of B, or my starting value, is 13.9. And you can see it actually is, yeah, that looks like it's right there, about 13.9. When you see that the starting value is pretty much right there, that means you're going to be using how many years since the beginning. So it's 5 years since 1970, 10 years since, and so on. When you see the value in this case, and this is a negative 18, and that's not the number here, that means that the Excel, the graphic here, actually went back in time to the literal year 0. So, I mean, if we can keep following this line back, oops, sorry. Yeah, back, it's actually going, back in time to the year 0. And so you would, in that particular case, when you don't see the value along this axis and you see the years here, that means for your X value, you use the actual year. Okay, so there's two different ways of using these linear equations, and you want to make sure you're using the correct value there. All righty. Okay, so this is, again, it's another example. And then it's talking about how to use Excel for this. Okay, so in a nutshell, this is section 8. All right, section 9 is talking about exponential modeling. So when we start going through and we're comparing data, when we notice that the absolute change is the same from the previous value every time, that means we're dealing with a linear model. Okay, if the relative change was the same when we're dealing with sets of data, then that would be exponential. So make sure you know the difference, because it's highly likely, hint, hint, that you'll be given a situation and they'll say, is this a linear model or an exponential model? And you need to know the difference. And one of the ways to know the difference is by absolute or relative change. Remember, if it's just the exact same value each time, then it's linear. If it is a percent of change is different, the relative change, that means it's exponential. Okay, and so what would be our model for exponential? It's the amount. In other words, sometimes they say y equals the initial value times, and in this case, they're showing growth factor because we're showing things that increase, but it could also be the decay factor if something is decreasing, and it's raised to the time period. Okay, how do we find the growth factor? There are 3 different ways. One way is they're going to give it to you. If they say something is doubling or tripling, you know the growth factor is 2 or 3. Okay, another way is to take 1 plus the percent increase. And notice it says the percent change is written in decimal form. So if something is increasing by a percentage, you want to convert that percent to a decimal and then add that. So if something is increasing by 6%, convert it to that decimal and add it. Okay, the third way of finding the growth factor or the decay factor is using 2 consecutive data points, and it's the new divided by old. So if we take that and we divide that out, we'll get the either the growth factor or the decay factor immediately there. Okay, so remember, we want to look at that, and we can always replace the amount. Sometimes they say y equals. Now, follow the order of operations correctly. Notice it shows 3 different ways here. So if I wanted to find the value, the first thing I'm going to have to take care of is what's in the parentheses. And that's just simply done for me. That's the growth factor or decay factor is already there. And notice this is a value more than 1. Anytime you see a value more than 1, it's automatically a growth factor. If it's a number less than 1, it's a decay factor. Okay, so the first thing I'm going to do is raise that to an exponent, and that raise it to the 6th power. There's 3 different ways you can do that in your calculator. You might have this little up arrow, they call it a caret button. So you might just take 1.06, hit this button, and that's going to say raise it to the 6th power. Or you might have a Y raised to the X button, or you might have an X raised to the Y button. Make sure you're using the same calculator that you're familiar with there. Okay, scientific calculator or standard calculator, we do not allow the graphing calculators. They'll actually stop you at the testing center there. So be careful because it's listed in the testing form there. Okay. So here's one way that we can look at the difference between linear and exponential. Exponential will start out relatively slow, but remember it's based on exponential growth, which means that eventually it's going to start to increase very rapidly, but the linear is just going to stay at that steady rate there. Okay, so that was exponential growth. Here's a situation where they asked you to figure out the different patterns here. So if I looked at relative change in all these cases, we can see that, this last column here is the one that had the standard had exponential model because the relative change was all the same. Okay, so that might be something they might ask you to do, and then they say, okay, from that, now create the equation. So exponential decay is just going in the opposite direction. Same idea, amount equals the initial amount, only this time we have the decay factor raised to the time period. How do I find the decay factor? Well, they're going to either give it to you, like saying something is decreasing or cutting in half. So that's 0.5. If it's cutting in half, that means it's a 50% decrease. So you're going to take 1 minus the percent decrease. And remember, we put that in the form of a decimal. Or once again, new divided by old if you have 2 consecutive data points. Okay. So we talked about this idea of the antibiotics. So we were able to use the idea of 2 consecutive data points to calculate what the decay factor was. Be careful, if something is decreasing by 30%, 30% is not my decay factor. It is decreasing by 30%. So we would take 1 minus 0.3, and that's going to be 0.7. So 0.7 is actually my decay factor. So be careful with that. Okay, and so that's pretty much exponential growth and decay. We just had many examples here, and that brings us to, and it does relate to interest. Okay, so exponential growth is pretty much how we look at compounding interest. Now, the first type of interest we have is simple interest, and that is pretty much, in this particular case, I equals PRT. That'll give me my interest rate. Okay, then I can add it to that principal, which is either the money I'm borrowing or putting in the bank. Okay, so these equations here for all of the interest formulas will be on your reference sheet. You just need to make sure you know which to use in each particular case there. Okay, compound interest. Compound interest compounded annually means it's only going to be compounded once a year. Okay, and that would be the formula you're using. And then we have compounded periodically, which means you're going to be putting the number of times it's compounded in a year in your equation here. So all 3 of these formulas are listed in your reference sheet. It's pretty obvious which is which. The only tricky part is, so once I plug in my values here, make sure you're using your calculator correctly. So do this division first, then add 1. Then you're going to raise it to that total exponent. In this case, it's going to be 12. Then finally, you're going to multiply by that principal. Remember, you always are multiplying by that principal last. Okay, so watch your order of operation. That's the most important part here. Okay, and then we had some example problems here. Now, there is a way that we can kind of guesstimate when our money will double, and that's called the rule of 70. So we can guesstimate when anything is going to double as long as we know the rate. Okay, so in this particular case, it said their bank is going to be growing at 3.5% for your deposits. So if I deposit some money in the bank, when will that particular amount double? Rule of 70, take 70, divide it by the percent. And notice the percent is just as is. We don't have to convert that to a decimal. So it says it's going to be 20 years. So we could also use it on other things besides money. And in this case, they were talking about population. So if the population growth rate of Liberia is 4.5%, when will their population double? So we're going to take 70 divided by that percent. So their population is going to double in about 15.5 years. Whereas Spain has a very stable population rate. It's really not going to double unless, maybe in 1,000 years. So their population and their growth rate is pretty stable. Okay, so then that's that rule of 70. So that's all that material in a nutshell here. Okay, section 10, credit cards. So remember, a credit rating, the better your credit rating, the better the APR rate is going to be that you qualify for. And it really does make a difference when you have a lower APR rate, annual percentage rate there. Okay, so it does make a difference. You'll pay less in interest. Okay, remember when you're paying something off on your credit card, you will get a grace period to pay off the total amount. But if you don't pay the total amount, then you're going to have to pay the finance charge. So remember, the finance charge is the first thing that gets paid first with your payment. Anything left over actually goes towards the actual balance there. Okay, so I know we did something where we were filling in a table. Let me take a look at that. So in this case, here is a sample showing what this student had with her credit card. And we were starting to look at these values here. Okay, what would be her finance charge? Remember, if I want a monthly finance charge, we take that APR rate in the form of a decimal and divide by 12. And then we multiply by that carryover balance. Okay. Let's see, I want to make sure I show you one of these problems that you might run into. Okay, so if you're given a chart like this and you're asked to fill in the missing values, remember finance charge, and we're talking about monthly, you're going to take whatever that rate is, that APR in the form of a decimal, divide it by 12, and then multiply by that carryover balance. Okay. And so that's going to give me $57.48. My new balance is these two values added together. Now, what's my minimum payment? Well, they're either going to tell you it's a percentage of your new balance or like a minimum dollar amount, like $20. In this case, it's a percentage. And so if I take the percentage, you can see my minimum payment is going to be $91.72. So what is my carryover balance? Be careful. This is one of the most missed mistakes I see on these kind of tables. In this particular case, we take $91 subtracted from the new balance, not that carryover balance. Okay, because remember, my payment has to pay for the finance charge, and then whatever's left over pays for my actual balance. So when I take these last two and subtract, that's what is my carryover balance. And then we just start this all over again. Okay, so hint, hint, if I had to do something like this, would I know how to properly fill in a table like this? Make sure that you are rounding your values out to the correct penny. Okay, so watch out for those. Okay. Remember, finance charge, monthly finance charge is the APR in the form of a decimal, divide it by 12, then multiply by that carryover balance. That'll give you your finance charge. Add these two together for the new balance, find the percentage that they're saying is going to be your minimum payment, and then subtract from the new balance, and that's what your new carryover balance is for the next month. Okay. And that's pretty much credit cards in a nutshell there. Okay, section 11, we had loans. And so in this case, we were looking at, once again, APR rates, and we were looking at some formulas. So you definitely want to know the formulas. Which formula would you use in which particular case? And it just so happens that these formulas are on your formula sheet. So that reference sheet there is going to help you out. So if I want to figure out what my monthly payment is going to be, I'm going to use the payment, PMT. It looks like the word payment, all right? But be careful. Sometimes they like to trick you, and or if they're asking you to type it in, remember, anytime Excel wants to do a calculation, you have to put an equal sign first, then PMT. Be careful. It's not PMT equals. That would be marked wrong. So watch out for that. That seems like a common mistake I see. Then you're going to be taking the monthly interest rate, so that APR divided by 12, comma, number of payments, comma, and then the amount of the mortgage here, and that's usually a negative value because it's coming out of your pocket. Oh, let's go to the next slide here. So if we had all these values, this is what it would look like. His APR is 3.75%, so he puts it in the form of a decimal divided by 12, comma. He's got a 20-year mortgage, and he pays it every month, so 12 times a year, so 20 times 12, comma, and then the entire amount of his mortgage after his down payment is $92,720. Okay. So know how to put these, if they gave you the values and they ask you, what would you put into Excel? Know how to type that into Excel. Also, if they ask you to calculate what would his mortgage payments be over a certain amount of years, or how much interest would he pay, so these next few questions right here, questions 5, 6, and 7, are very important to know also. Okay, and remember, if they're asking you the ratio, anytime they're asking you the ratio, they're telling you the order it wants to be of the interest to the total mortgage payment. So here's what he pays in interest is that $39,000 number. His total payments is the $131,000 number. Okay, and this would be his ratio there, or he's paying what, 29.7% in interest. Okay. All righty. Then if you had to use it in other situations, you can use this to figure out a car loan, what your payment would be for a car loan also. It doesn't just work on mortgages. All right. The next thing is talking about how much can somebody afford. So in this case, they gave us just one example of a total expense ratio, but just like in our project, we made it much easier, and we just said, I don't remember if it was 1/4 or 1/5 of your gross monthly income. So we made it easy for you, and we just said that's going to be your maximum mortgage payment. Okay, whatever that fraction of your monthly payments or monthly salary is. Okay, so once you know how much you can afford a month, then you can actually figure out how much of a mortgage or how much of a car or any big item that you can afford by calculating the present value. Okay, so PV means present value. In other words, what can I afford to buy in the present right now? All right, so, and I have to know the amount of my maximum payment that I can afford. Okay, so in this particular case, notice monthly interest rate is the same like we've done. Number of payments have been the same. The only difference is the last value. This is how much of a payment you can afford. Okay, it's not calculated from the payment formula. It's actually calculated from an expense ratio, or they say, you know, 1/4, 1/5 of your salary, something like that. Okay, so then when they put it into Excel, Excel gives them that you can afford this value. Okay, so just know if they ask you something like this, how would I put the numbers into Excel? Okay. And that's pretty much it in this section for loans here. So loans, you've got payment, PMT, and you've got present value, PV. Now, our last section talked about retirement plans, and retirement plans are basically like 401k plans. Okay, and in this case, you're talking about putting money away for the future. Usually 40 years is the maximum because we figure people start working full time in their 20s and they retire sometime in their 60s, which is about 40 years. So that's usually about the maximum. All right. So remember, in this case, that if I want to know how much money I'm going to have in the future, I'm using future value, or FV. So remember which these initials stand for here. Okay. And once again, it's going to be the monthly interest rate. So your APR divided by 12, comma, the number of deposits this time is what's here. I'm going to put something away every month, so 12 times a year for a maximum of 40 years in this particular case, comma, and then the last value is how much money is being put away in your behalf. If your company matches funds, so say that you're putting away 150 and your company will match half of that. Well, half of 150 is 75. If I add those two together, I get 225. So $225 is what's being put away in my behalf. Once again, it's a negative value because it's coming out of someone's pocket there. Okay, so know how to set these up also. Okay, so know these three financial formulas. What would I type into Excel? We always start with an equal sign there. Okay. Okay, and then just like she had here, how much did she deposit? How much did the company deposit? How much interest was earned? And how much total did she make off of this? Or what was her total amount, you know? So make sure you know how to break down those values there. Okay. So pretty much that's the last section that we have here. Okay, so I'm going to open it up if anyone has any questions about anything for the exam. Those are pretty much all the topics and the things you want to watch out for and make sure you're concentrating on. Those of you who joined us late, you want to make sure that you are doing the review quiz. The review quiz can be found in Module 6. So if you click on Module 6 here, okay, so here's Module 6 overview is where exam number 2 is located. Make sure you do the review quiz. Okay, it is required that you do it anyways. And, you know, take it multiple times because there is pretty much a direct correlation on how well you do on the review quiz to your actual exam grade. It really does help, especially on this exam 2. Okay, usually exam 2, when they work on this a lot, I get some really high grades. Okay, So if you have no other questions for me, this is all I have for you. Otherwise, I'll hang out on the line if anybody has any other questions about what'll be on the exam or anything else. And good luck.